Okay. Hello everyone. Now today I want to discuss about Gauss law. So Gauss law, what is the general formula of Gauss law? Right. See, here I will tell one thing. I will consider area as a vector quantity. How? Suppose we have this type of parallelogram present, or you can tell suppose square present, and suppose this is a y-axis present here, and this is a assume x-axis present, and this is z-axis, right? Assume this length it has given in terms of vector, and that the value of this length is a vector, correct? And suppose this is given a vector, I'm telling, and this will be also a vector, am I correct? And this also be vector. I'm telling what is the area of this square? Area of this square of parallelogram, it will be equals to a vector cross b vector. One thing I want to tell, in case of I told already there are two types of means system, means first is called open. There are two types of surface present in physics. I will use concept generally two types of a surface. There are, I'm writing here two types of surface present. First is called open surface, and second is called closed surface. Correct? Open surface means two-dimensional object. Example? Tell me example. Example is square, triangle. Correct? Disc. It is called two-dimensional object. What about closed surface? This is called three-dimensional object. Correct? An example here, keyboard, correct? Keyboard. And next, you want to like prism. That is also called a three-dimensional object. Next, I am telling you. Suppose what is flux? What is the definition of flux? So, write first definition of Gauss law. Gauss law. According to Gauss law, the net electric flux, through closed surface is equals to 1 by epsilon times the total charge enclosed by that given surface. Right? So first write here what is the means Gauss law mathematical equation. Phi total equals to phi closed surface equals to summation of q enclosed upon epsilon naught. Right. Next thing you can write here, cyclic integration of this also called phi total equals to cyclic integration of A dot dA is vector quantity, area is also vector quantity. I want to tell one thing here. See, suppose we have a just around here. See, I am telling about open surface. Open surface means two-dimensional object. Correct. Here, suppose we have a one square present here, and suppose this square is lying along xy plane. And asking one question, you tell me what is the that I told already. I will consider area as a vector quantity, right? So tell me here what is the direction of area vector? See, now you can assume this thing. Suppose we have this type of this rectangle present here, right? And that rectangle I have kept that in xy plane. So area vector either your side or inside, means either perpendicular to that board or inward, outward or inward. Which means that here area vector I can write area vector, suppose it will be plus c x, okay, y. So whatever perpendicular, that will be z axis, correct? So area vector will be z axis, one word. And that is also minus z, both are correct. I already told in case of open surface of two dimensional object, there are two direction of area vector will exist. But what about closed surface? Suppose we have this means a cuboid version here. Cuboid. How many surfaces are in cuboid? 6. How many surfaces? 6. Just writing here, see. This is a cuboid version, right? This is cuboid present here. So how many surfaces? First, second, third, fourth, fifth, sixth. I am asking one question. This area, that is means about my side. What is area vector? This will be outward always. In case of three-dimensional object, otherwise, in case of closed system, closed surface, area vector always outward and perpendicular to the given surface, right? So this is the general assumption about closed surface. Next, I'm asking a question. Suppose you have a sphere present. In case of sphere, what is the direction of area vector? Radially outward, perpendicular to that given surface. See, this is closed surface, means here sphere present here. Sphere. How many? See, there are many infinites. I can choose. This is D. This is radially outward. D vector here. This is radially outward. D vector. D. This is also radially outward. Always it will outward, and if you extend the backside, it will pass through the center of that given sphere, right? So always area vector will be existing in case of three-dimensional object that is also called closed surface. Area vector always radially outward, or outward direction and perpendicular to that given surface. That given surface, right? Just asking a question. See, taking one example here. So some important point about Gaussian is Gauss law, right? So important point about Gauss law, correct? Some important point about Gauss law. See, Gaussian surface should be symmetric about the charge distribution, right? Again, this is assumption. If you will, I don't think I will tell. It's Gauss law always applicable, but not always useful. That is Gauss law always applicable. Always applicable, but not always useful, correct? Right, first assumption here. The Gaussian surface, should be symmetry. The Gaussian surface should be symmetry about given charge distribution. About given charge distribution. Next, it says that suppose we have a spin charge belt. So I want a Gaussian surface So Gaussian surface, you can draw one means symmetric surface. This is also correct. We can draw here cube, right? It's also symmetric surface. In this case, you can calculate Gauss and its flux through this Gaussian surface easily. So this is considered as a first item sum symmetric surface is it will be required. Next, electric field must be symmetric. See. Second point, electric field must be symmetric. Next, Gaussian surface must be passed through, must not pass through any charge. See here, Gaussian surface must not pass through given charge. How? See, suppose I'm feeling this is charge right here and draw Gaussian surface. So you cannot draw Gaussian surface passing through this charge, right? Here you cannot calculate flux, right? This is wrong. Next step. And you know what is the flux formula? Phi equals to E dot A. Phi equals to E dot A, correct? This will be E A cos theta, correct? Phi equals to E dot A, this will be E A cos theta. So here we can add something up. Theta must be same for all point. Theta must be same for theta must be same for all point. Generally, I am telling one thing must be same. Theta must be same. It's angle. What is theta? Tell me. Angle between electric field and area vector. Suppose I am telling us this is your plus Q charge band here. Now draw on the core surface. Okay. Suppose let us spherical. Tell me here electric field. What is electric field direction? Area outward. What is area vector? Outward. Generally, you will get angle will be 0 degree or 90 degree generally, or 180 also. Means 0 or 180 it will be considered. Correct. Generally 0, 90, 180. Not like 45. So generally this is the difference. Here also tell me what is area vector? Area outward. What is electric field? Area outward. Here also, suppose I am asking this is Q equals to Q. So through this first surface of this cube, assume here electric field line is passing through this surface, right? So what is area vector here? See, this is a keyword present here. This is your first surface. Here electric field line is passing through this surface. Area vector by side, but electric field opposite side. It says that electric field plus x-axis, assume this is x-axis. X, y, means x and y and z. So this is electric field along plus x. Area vector of this surface my side. What is the angle? 180. So in this case, okay, this 180 angle also exists. Suppose 1% is given. This is a half a bowl percent here, half bowl percent here. I am asking, I have kept here charge. Tell me what is the flux through hemisphere. See, first make symmetrical bowl, right? This is to be solid sphere. Now tell me now this is your closed surface, and according to Gausss law, now we can apply the flux formula by Gausss law. That will be phi closed system equals to Q equals upon epsilon, right? So this is flux through complete sphere. What about phi hemisphere? this will be half of flux through closed surface, that will be 1 by 2 q by epsilon. Correct? Next, tell me. Next, suppose I am taking example about solid angle. What is solid angle? See, here suppose disk present here. What is this? Disk. Here disk present, right? At distance, suppose t, I have kept here charge. Right? Tell me, due to this charge, flux will be passed through every direction. Like here also, here also, here also, here also. Also, flux will pass through every direction. Actually, due to, I told already, due to point charge, flux will be spherical. Means electric lines will go means in a closed sphere. Okay, but see, just I want to calculate what is the flux value through this disk. If you will look, if you will observe carefully, through this disk, the flux, here electric lines are passing, and that will make a cone, right? That will check here. I want to calculate how many flux passing through this disk. That is, I will use here solid angle. That is called cone. Here charge q percent. Suppose angle theta, this angle also theta. So flux through cone. Flux through cone. It will be equals to q by 2 epsilon naught 1 minus cos theta. Correct? What is cos theta? Angle subtended with horizontal axis and on this circumference line. So this is flux through cone. Correct. I am taking one example here. Suppose we have one solid, means it's a hollow cylinder present. Assume this distance it has given 2r, and this radius r given, right? At the center, one q naught charge length. Tell me, due to this q naught charge, and how many surfaces present in case of cylinder? How many surfaces? 3 surfaces. First is this flat surface, that is first surface. That is second flat surface, second surface. Correct. Next, that is curved surface. Curved. So, suppose this is a cylinder. This is flat surface first. Second surface, that is curved surface. 3 surface will be. So I will use here what is Gausss law. Correct. So tell me, due to this point charge, electric field lines will pass toward every check, every direction. Actually, this will make a solid sphere. Check. I solid because Gaussian surface will be always closed three-dimensional. So solid sphere, or sphere you can tell, right? Next thing, I am telling one thing here. Tell me what is the flux through surface first, and what is the flux through surface second. Correct. And what is the flux through surface curved surface. Correct. Curved surface. So tell me one thing. This from, if you check carefully, check this through first surface. This first surface, right? This will make a cone. Check. Cone it is from here. And tell me, what is angle here? 90. This angle also 90. This angle 90. This angle also 90. Tell me, this complete distance 2 are given. What about this distance? Small r, means capital R. And this will be also R. Correct. This total angle 90. So this will be 45. This will be also 45. So parallel this is nothing but flux through cone. And what is formula? Q by 2 epsilon naught 1 minus cos, what is angle check? 45. So that will be your answer of first. What about surface? Second, it is also equal. Why? Because this also cone. You can write here 5 through cone is nothing but 5 through cone surface 2, and that will be Q upon 2 epsilon naught 1 minus cos of 42. Next, you can do one thing in case of curved surface. So curved surface means phi through radiusing. Or we write first plus r plus 2 second plus third equals to q upon epsilon, right? What about first and two check? Here we can calculate one thing. Say, I want to calculate flux through curve. This third, right? So can I write here phi 3 equals to q upon epsilon naught minus phi 1 minus phi 2. That will be your answer. Okay? That will be your answer. Thank you.